instead of coding in Python or Scala, you're going to be coding in English.
So you try it, it's not working, you change the query, try again, the test works, and like it's super fast.
So you'll say, I want to copy data from there to this spot in the catalog, and the system will take care of it for you.
We're simplifying more and more this user experience.
There is no migration, there's no breaking changes. You'll get incremental improvements to the existing products as you're using them today.
Hi folks, hi Q. Today we're hosting Michael Armbrust, a distinguished engineer at Databricks. He designed Spark SQL, then streaming, then Delta, and now he's focusing on the next generation of data engineering. And my question is there anything Michael doesn't do?
You're too kind.
All right, so maybe to get it started, I wanted to, Michael, to talk about the overall data engineering ecosystem. Like Spark is, I think it's 10 years old, maybe a little bit more.
A little more, I think.
Yeah. I was wondering, like, what do you see in the market? Like nowadays, if you are a new data engineer, which tool would you be using? Like Spark, but do you do also Python? Do you do Scala? I don't think so anymore, really. Maybe SQL. To use AI to build everything. I don't know. How do you see the market?
Yeah, I mean, well, I think if you look at even just the history of Spark, we have been slowly up-leveling Spark over time. So, like before Spark, there was Hadoop. And you had to spell out every little detail. You had to have these different like output writers and input readers that would control exactly how the data was serialized. You had to write out your algorithm in full detail. And Spark made that a lot easier. It gave you these like simple functional commands where you could map and reduce and do this stuff, but all in just like a few lines of Scala code. And then we added Spark SQL to it. And like that was a big simplification where now you could use data frames in Python, data frames in Scala, or just plain SQL commands to run it. And so I think this trend will continue to have kind of higher level abstractions on top of it. And I think, really where we're probably heading is instead of coding in Python or Scala, you're going to be coding in English. You will talk to an LLM in English, which is this like messy, ambiguous language, and the LLM will produce Python, Scala, SQL, one of these unambiguous languages, and that'll kind of be how you're working. And I think that's good. That trend upward is going to continue.
And what's the big chunk of language you see running on Databricks? Is it SQL or is it Python?
I mean, I think that it's pretty split, but definitely SQL and Python are the ones that are growing, and Scala use is declining over time. And I think it really, between SQL and Python, it's more of a persona thing. It's really, if you know SQL and that's your preferred tool of choice, you continue coding in SQL. If you want to do more procedural coding, if you have like a bunch of steps and you want to orchestrate them together and you want to modularize your code and you want to interact with libraries like PyTorch or these other things, then you're probably using Python.
And DLT was introduced 2 years ago. And can you share a bit on the story around DLT?
Yeah, totally. So, DLT has gone through quite a few evolutions over time, but really the goal was exactly what I said at the beginning. We want to keep up-leveling the task of doing data engineering. So, when we were building Spark SQL, we were building this very generic tool for executing declarative SQL queries. And the magic trick of that declarative language is instead of saying like, in order to compute an average, I will first do a sum and I will do a count and then I will divide them. You just say, give me the average, and the system figures out the right way to do it, where the shuffles need to go, where it's going to do partial aggregation. All of those different steps just kind of happen automatically. DLT is the next level where we want to make the entire process of doing data engineering declarative. So now there are actually verbs for create this table and create it up to date and keep it up to date, or do change data capture and handle all of the out of order data and keeping history and all the other things you need to do. You just say what you want to have happen and the system will figure out how to do it. It started off as, when we first created DLT, the product name was probably going to be serverless streaming. the idea was just take Spark Streaming and make it easier to run. Add all of the retries and the metrics and the auto scaling and all the things you need to do to run a streaming application without having to tune a whole bunch of knobs. But what we quickly learned was continuous streaming is a tiny fraction of the data engineering people want to do. It's great when you want low latency, but it's pretty expensive. And also, streaming has this fundamental, it's both a limitation and a superpower. Streaming promises it's only going to read the input data once. And so the types of things you can compute with it are limited, but also it's guaranteed to have a certain performance. And so over time, DLT evolved from this kind of very focused on continuous streaming pipelines to a generic tool for doing data engineering, but declaratively.
Yeah, I feel like it's like we say streaming, but it's more incremental pipeline, and then you can decide like the latency. Do you want it running every day or like every second? It's up to you. But like the key is an incremental pipeline.
That's exactly right. Yeah, that's one of our magic tricks. When people hear the word streaming, they often think super complicated, super expensive in order to get the lowest latency. And Spark can do that, and DLT can do that, especially with the advent of real-time mode, which is something that's in private preview right now. We're actually now able to run continuous streaming pipelines with sub-second latencies, which is competitive with some of the best streaming platforms that are out there today. But the really cool thing about Spark, and the thing that nobody else kind of in the streaming space can do, is you can tune that cost latency trade-off. To me, streaming does not mean necessarily low latency. It can mean that, but it's exactly what you said. It means incremental computation. It means reading the input only once. And it turns out a lot of data engineering is exactly that. When you're ingesting data, you only want to read it once. When you're doing transformations, you only want to read the input once. And with triggered streaming inside of DLT, we could do that super easily. And the best part is, unlike when you were using kind of plain Spark, when you go back between triggered streaming and continuous streaming, you don't need to make any code changes. So if your business requirements change over time, it's one click in the UI to change it to a continuous streaming pipeline and get those super low latencies.
So doing incremental, like if it's new data and you just want to append the data to an existing table, like I can see how it's kind of simple. You just consume the new data and you append that to the table. But in most of the pipeline we have, like you want to do something else. You want to do aggregation. Maybe you want to join with other tables, creating views and stuff like that. And I think that's a really hard stuff because most of the time, if you do it yourself, you would have to recompute everything. And I know DLT has some magic behind the scene to help with that. Can you share and tell us how it's working?
Yeah, absolutely. And this is, I think, one of the biggest challenges people have when they're understanding DLT is like DLT has several different abstractions. It has tables that have streams writing to them, and it has materialized views. And really the trade-off between these two abstractions is, like I said before, streaming has this limitation and this superpower that it only reads the input once. And that limits the types of queries you can write. So you can do aggregations, but you can't really do aggregations where you need to keep arbitrary amounts of state in memory. So for example, if you wanted to do like histograms over arbitrarily large data sets, streaming is not a super great thing for that. You'd want to use like a sketch and do an approximate histogram instead. You want to do time window averages where the data arrives in a bounded amount of time, streaming is a perfect case for that. But you want to do outer joins, window functions, these more complicated things, then materialized views are the right solution. Materialized views are still incremental in many cases, and as we improve the enzyme query optimizer, that's kind of the new system we put on top of Catalyst that not only understands how to optimize queries, but knows how to update existing results to queries efficiently when the input changes. But enzyme can run all types of queries. It can do joins, it can do outer joins, it can do aggregations, and the magic trick is it's allowed to read the input again if it needs to. So let me give you an example of where that would be necessary. If I'm computing a max and the maximum value is deleted from the input table, well, now I have to go back and look at the input table and find out what the next maximum value is. That's something that streaming could never handle. It can't do retractions. It can't understand the idea of data disappearing because that would require sometimes arbitrary computation. Materialized views will automatically take care of that. So in the cases where it's possible, it will be as fast as streaming. It'll do exactly what you said. It'll read only the new data, append it downstream, everything will be fast. But in the cases where something changes, or in the cases where there's an expensive operation that requires extra work, materialized views will also do that transparently. So there's this trade-off between guaranteed performance and expressive power. And what that means is you can really kind of, no matter what your requirements are, you can get DLT to do them. You just need to kind of think about what's more important to you.
And like DLT, like in the past, we could not choose any like what we call the runtimes. You just choose, let's say, the number of workers and the type of machine, and that's it. Now we have serverless, which also gives like simplify more the deployment of a DLT pipeline. But can you tell us more how does DLT work with serverless and how this can help the customers optimize their cost, but also the performance?
Yeah, totally. So serverless is, not only a DLT feature, it's something we're kind of doing to simplify the entire Databricks platform. And the nice thing about serverless is you no longer need a cloud account. You no longer need to worry about IAM roles or all of kind of the setup of whatever cloud you're running on. We take care of that for you. And it has a couple of magic powers. So one is you can now sign up for Databricks with only a credit card and go all the way to processing massive amounts of data sets without managing any other infrastructure. You don't need to worry about quotas or any of that kind of stuff. But also, serverless has a couple of magic tricks. It's got a super awesome auto-scaling algorithm that works not only in DLT, but across all of the other products. And it has, one of the kind of cool parts of serverless is we only charge you for the compute that you use. So it's on us to figure out how to allocate those machines and how to bin pack them and do all of these other things. And you're only ever paying for the capacity that's actually doing useful work for you. Serverless also has a bunch of performance features because since we manage the entire stack, we can do things more quickly in some cases. So especially with streaming workloads, we can pipeline different, we can do streaming pipelining and execute multiple micro batches in parallel. We can automatically tune the admission control parameters, things like max files per trigger, since we know exactly how big the cluster is and how much extra space there is and how much space there is in the warm pool. We take care of all of that automatically. And so in some cases, we've seen that serverless can be both faster and cheaper for large scale streaming ingestion jobs and simpler.
So we have DLT, and within Databricks you can use DLT like as a product and create your DLT pipeline. But then you can also create materialized view, which I think are using DLT kind of in the backend. I know also when you create vector search, for example, we are using DLT in the backend. Are we starting to build everything on top of DLT like as an engine and then offering higher level function to customers? Is that how it's working?
Yeah, so I think the right way to think about this is, DLT is like it's a brand name and it's an enabling technology. And what DLT, that engine, that runtime is good for, is it's good for doing data engineering. It's good for reading data from one place, transforming it, and writing it to another place. And it simplifies a lot of that work. And of course, even some of the products that we do internally have that exact same problem. So system tables are built with DLT. We do our own internal security with DLT. When we're moving data into an online table or into a vector index, DLT does that movement. When you're ingesting data using Lakeflow connectors, that also uses DLT. But really, the abstraction when you as a customer are using DLT, there's kind of a few things you need to know about. You need to know about streaming tables and materialized views, which we talked about a little bit. You need to know, if you want to do advanced things, you need to know about flows, which are actually like, it's streaming, but it's also things that aren't streaming. Like, for example, doing one-time backfills. So if I want to have a single table, I want to do a one-time backfill, and then I want to read from two different Kafkas in different regions and write into that table, then you're going to start using flows. And then the final DLT abstraction is a pipeline. So streaming tables and materialized views you can use just on their own. You can just go into DB SQL, say create streaming table, say create materialized view, and the system will automatically manage everything. You don't need to know any other concepts. Just one line of SQL can build a highly scalable ingestion pipeline that's automatically managed. But when you're doing like a large data engineering task, you want to do the kind of full software development lifecycle. You want to have source code that defines all of the tables. You want to version control it. You want to deploy all of those assets together. And that's where pipelines come into play. A pipeline is just a collection of streaming tables, materialized views, and flows that are deployed and execute together. And so just think of it as like a management abstraction on it. So kind of just to summarize, DLT is this enabling engine that lives under the covers. The important things for you to understand are these streaming tables, materialized views, and pipelines.
Okay. And since you mentioned MVs and STs, when it comes to developing code, I know it can be it was in the past a bit tricky to debug the code when developing on DLT, and I've seen that we're simplifying more and more this user experience. But can you tell us more on this part?
Yeah, totally. So I think one of the first steps we did was these DB SQL materialized views. So now you don't need to do any extra setup. You just run a single SQL command. It runs like normal and it creates a DLT object. But even for more complicated pipelines, we're spending a lot of time on the developer experience this quarter. We recently decided that basically this is we really like this underlying technology, but we think the user experience of doing development has been holding us back a little bit. So we recently did a pretty big reallocation of engineers to get a lot more people working on improving that developer experience. And there's a couple of things we're working on. So one is DLT has this magic power called analysis. Because DLT is declarative, we can actually analyze all of your code without actually running it. So we can look and say, are all of the tables in this pipeline valid? Are all of the column names, table names, data types, functions correct without actually doing anything to the production data? And that's something that's really only possible when you have a fully declarative language. You can't do that with something Turing complete. And so basically what this lets us do is what we want to do is when you're editing, you can run these validate commands, but we want to make that validate operation so fast that it can be continually running in the background. So we have a bunch of benchmarks that we're doing right now. We're basically once a week, we're reporting all the way up to Ali, our CEO, exactly how long it takes to analyze a single table, how long it takes to analyze Python versus SQL, how long it takes to analyze a table, a pipeline that has 100 tables in it. And we're going to spend a lot of time optimizing that. So doing things in parallel, skipping steps where nothing is changed, removing redundant work that we're doing. And we want to get that to be super fast. And I think what you're going to end up with is something that looks a lot like a cloud IDE for doing data engineering. And I'm pretty excited about that because I think I think we can actually kind of, today people are very used to notebooks and there's this really nice interactive experience, but also you have to make sure that when you run those notebook commands, you're not breaking production. And I think that's a trick. That's a pretty dangerous thing and maybe not the best way to do. It's a great way to do, I think, data science, but it's not a great way to do proper software engineering. And so I think with this new investment in the development experience in the Databricks workspace, we might actually be able to leapfrog notebooks in terms of what it's like to do development of production data pipelines.
And what about unit test? I think unit test has been like a challenge forever in data engineering because you have to bring the data, you have to test the transformation, the input, the outputs.
Yeah, that's a great question. And it's actually something that we spent a bunch of time prototyping. When we built the first version of DLT, the first version of DLT was this thing I built on my laptop that just reached out and used Databricks APIs to run a job. And that first version had this really cool unit testing framework. Because again, another magic trick of declarative programming is we can substitute things in the graph. So we can say, take this data flow graph that you've defined. This table reads from this table, writes to this table. And we can say, well, actually that table is the production data. Let's substitute in this sample data instead and see what result comes out at the end. So we don't know the exact shape of this, but we do really want to build data tests where you can say, given this input, make sure this output exists and have tens or hundreds of those examples that the system runs automatically for you.
Yeah, that would be awesome. And if you can have that and I don't know, kind of live, trying it, you try it, it's not working, you change the query, try again, the test works, and it's super fast. I could see how it could speed up everything.
Definitely.
And I have a tough question. I think this one came a lot. Is DLT going to be open source at some point?
Yeah, so Databricks has a long history of doing open source. We started around this open source project Spark. The first major project I worked on at Databricks, Spark SQL. I remember the day that we opened that, I think it was 11,000 lines of code PR against Apache Spark to kind of open source that as well. Delta was open sourced. So we absolutely want to open source DLT. It's just a matter of engineering. We need to make sure we have the right engineering capacity. And right now, our focus is on making sure the experience inside of Databricks is as good as possible. But we'd really like to work with the Apache Spark community. We think that this is a fundamentally better way to write data engineering programs. And we'd love to make those kind of the standard APIs in Spark for doing it and have some kind of simple runner in open source that could run DLT programs as well. So stay tuned. It's something we absolutely want to do, but right now our focus is on making sure the experience in Databricks is as good as possible. The one other thing I'll say is the most important parts of DLT are already open source. The data that DLT produces is stored in Delta and is available in Unity Catalog. Those are both already open source. The transformations you're writing. The nice thing about Spark is it's not actually, the nice thing about DLT is it's not actually a new language for writing transformations. It's just Spark SQL. It's just data frames. And to me, the data and the transformations that have your business logic, that's the most valuable part. That's the part that would be very expensive to port to another system. But we want to make all of it open source, including the runner at some point.
And I see also often customers like asking questions about DLT and DBT, but I feel like DBT is just using under the hood the DLT computation at the end. But maybe can you explain us how it's working? Like and as a user, like do you have any lock-in starting to use DLT or DBT, and how you should be thinking about it?
Yeah, so I love DBT. I think we have very similar goals between the kind of the DLT project and the DBT project. This idea that rather than managing your data infrastructure as a bunch of ad hoc commands you run in production, that's just not the right way to do it. You want to have a version controlled description of all of the tables that are going to be inside of your catalog. And DBT and DLT are going to be very similar in that way. The key difference is, DBT runs outside of the database engine. So it basically, it does like Jinja templating to build SQL queries that it then executes against some other engine, and that limits what they can do. It's difficult to incrementalize queries or to do streaming ingestion or things like that. But fortunately, you no longer have to choose. There's a Databricks connector for DBT, or the Databricks adapter, and it creates two new materialization types, streaming table and materialized view. And so if you are already familiar with DBT, you should absolutely keep using it. All you need to do is use those materialization types, and you can get all of the power that is only possible when you actually own the entire compute engine. And if you're not using DBT, I do think DLT kind of solves a lot of the same problems. It makes it possible to kind of declaratively specify an entire graph of dependencies and automatically keep them up to date.
That's perfect. And I think now we will talk about Lakeflow, which also is going to be built on the top of DLT, if I'm not wrong. So can you give us an overview on what Lakeflow is?
Yeah, so Lakeflow is going to be the next evolution of the data engineering products inside of Databricks. It always used to be that there was Databricks jobs or Databricks workflows, and there was DLT, and they were seen as these kind of very separate entities. And part of that is one of them is they're just very different ways of writing a notebook to do data engineering versus writing DLT is kind of a different way of thinking. But really, I think that dichotomy is wrong. And the idea of Lakeflow is we want to evolve this so that it makes it very easy to use the right tool for the right job. And so the way I look at it is there's Databricks jobs, and which are now going to be called Lakeflow jobs. So really, DLT or Lakeflow is the evolution of all of these technologies. It's not just DLT; it's workflows, DLT, Lakeflow Connect, all of these things kind of wrapped into one coherent product. And so the way I like to think about it is there's Lakeflow jobs, and you should always be using that for production. A job is the way that you run something reliably, either on a schedule or when some other action happens, like a table gets updated, a file gets uploaded, some other job finishes. You should always be using Databricks Lakeflow jobs for that. Then there's notebooks. Notebooks are great for doing data science and investigation. You should continue to use them that way. Notebooks are also a great way to run legacy Spark code. If you've got data engineering that's already working and you don't want to change it, absolutely, that's the right way to run Spark programs. And I use the word program here kind of very specifically. When you have procedural logic that says, if this, then that, overwrite this partition, where you're actually telling the system how that data engineering should be done. You should continue to use notebooks, and you should continue to schedule it with Lakeflow jobs. And then what we're doing with Lakeflow is we're now moving DLT kind of into this same UI so that you can seamlessly create materialized views, streaming tables, and pipelines all within that same experience. So, often your data engineering job might actually have all of these aspects. If you want to start by downloading data from an FTP server, well, that sounds like procedural logic. So you should use a notebook for it. And then if you want to ingest that data into a table, well, that sounds a lot like a streaming table with autoloader. You should use streaming tables for it. And if you want to transform that data to build aggregations that are going to power a dashboard, you should use a materialized view for that and a dashboard, and you can put that whole thing into a Lakeflow job.
And what about AI? Because I've been using Cursor AI like to do all my Python stuff. Like it's so amazing. Like I'm just giving a few instructions. Like I got the Python, it's up and running, even SQL. Are we gonna inject a lot of AI within Lakeflow so that you can super easily build your pipelines and set up everything?
Yeah, absolutely. So I think the AI is already pretty good at writing SQL, and it's pretty good at doing Spark data frame operations. And so those parts should work seamlessly already, inside of Lakeflow and whatnot. What we're working on is, it turns out these large language models were trained on corpuses that were collected several years ago, before the DLT syntax existed. And so we're working really closely with the Mosaic team and the Databricks assistant team to make sure that we train it on this new syntax that we have produced so they can provide good answers for that. And that's actually kind of an effort that just started this quarter to really come up with a regimen for measuring how good is it at understanding our specific syntaxes that we've added on top of Spark, and how often is it giving good answers there, and how can we improve that with more training.
I can. Do you think like if you are a new data engineer, do you still want to learn how to do Python, or do you think like in a few years it's only going to be write some English, generate some automation, and that's it?
Well, it comes back to kind of what I said before. English is this messy, ambiguous language, whereas Python and SQL have well-defined semantics. You know exactly what they're going to do. So I think it's never a problem to be able to read and understand that ambiguous thing. I think that will continue to be a valuable skill because you'll be able to say, is what the AI produced correct? But will you be writing a lot by hand? I think that's going to be less and less. I will say, even in my own stuff at work or the stuff I do in my free time, I write less and less code. I let the AI write it. I look at it. I tell the AI how to correct it, and then I use it. Because there's just a lot of tedium in programming that goes away when the AI is writing it for you.
Yeah, it's super interesting. And by the way, things you mentioned about the Databricks assistant and DLT, this is something we talked about recently with Weston. Is leading the Databricks assistant team, and he told me about this new project to make sure that DLT is well understood by the assistant. I was just curious to understand. We did acquire Archeon or Archeon. I'm always struggling to.
I asked the founder the authoritative pronunciation.
Okay, so how will this integration of Archeon works with Lakeflow? Because I've seen Archeon used to have a lot of connectors, and now we're deploying. I think now we have. I think maybe ServiceNow will come next quarter. We Google Analytics, Salesforce, and more. So how does work this integration?
Totally. So all of this will live under the Lakeflow Connect umbrella, and just for people who haven't heard of it. Lakeflow Connect is going to be a no-code, point-and-click ingestion experience built into Databricks. So you'll say, I want to copy data from there to this spot in the catalog, and the system will take care of it for you. It uses DLT under the covers, but you don't need to know anything about DLT in order for this to happen. The Archeon acquisition was super valuable for a key piece of this, which is getting the changelog from these different databases. So DLT has always had this pretty cool technology called apply changes into, where given a change feed that has a primary key and some ordering, we will create a table that has the latest up-to-date copy, no matter what order that change feed arrives in, even if parts of it are later than others, and a bunch of kind of complicated distributed systems programming stuff there. But what we didn't have, the part that we always left up to our user, was how do you get that change feed? And that can be super difficult. You have to pay for Golden Gate. You have to set up open source projects like Debezium. You have to figure out a way to like get them up into the cloud, to get the results up into the cloud with Kafka, storing the data on S3. You have to build an ingestion pipeline to pull it in. And what we're working on right now is taking that super awesome technology that we got from Archeon and building it into the Databricks platform so that we can handle that whole step. You point us at the database, we get the change feed, we run apply changes, and we create those tables for you. And we'll be able to do this whether your database lives in the cloud, that's in in private preview right now for SQL Server already, or on-prem. We'll run what we call the ingestion gateway inside of your data center, behind your firewall, and it will upload only the data you want into a secure location in Unity Catalog, where we will then apply it into a Delta table. So Archeon is the thing Archeon is doing is it's giving us that change feed, for all of those databases, and then alongside of that, we've been building connectors for a lot of SaaS services. So ServiceNow, Salesforce, Google Analytics, SharePoint, Google Drive, whatever it is, we want to build a connector for it. If we don't have it, talk to your account team and let us know, because we're rapidly building that out. It took us a while to get the infrastructure in place, and now that we have a couple of connectors out there, I'm really excited to kind of start doing the breadth first search of the space, really building all of those out.
And Michael, one question. So the ingestion pipeline that we have to do all the CDC and ingesting all the changes, is it running with DLT? I mean, under the hood at Databricks?
Yes, yeah. It's all running on top of DLT. Like I said, you don't need to know anything about DLT in order for this to happen. But the nice thing is, if you are familiar with DLT and you want to do monitoring, it's the same event log, it's the same stuff. So if you are a more sophisticated user that's already familiar with this part of it, you can absolutely take advantage of that and have one single way to think about how is my data engineering proceeding, what's data quality look like, all that kind of stuff. But if you're, if you're newer to our platform, just learning SQL, or you're even just using the assistant, Lakeflow Connect is for you, because you don't need to do any programming. You don't need to know anything about pipelines or streaming tables or any of this stuff. All you have to do is authenticate with the source system, and we'll take care of the rest.
And if I'm not wrong, system tables is also using behind the scene DLT and then sharing the results with using delta sharing between our control plane and the customer's workspace.
Yeah, that's right. These are like implementation details, but I do love that we eat our own dog food and use our own software in order to do it. It turns out Databricks is actually one of the biggest customers of DLT. And yeah, absolutely. Some of the system tables are produced with it, and like you said, yeah, we use Delta sharing to share it securely with our customers. So always fun to see technology reused like that.
And you mentioned at the beginning that all our offering is serverless, and that's true, of course. But is Lakeflow going to be mainly serverless or not?
Well, one of the key things of Lakeflow is we really want to evolve the existing products. I know that moving to Unity Catalog and other stuff like that, those were big migrations for customers. Migrations can be painful. And it's super important to us that with Lakeflow, there is no migration. There's no breaking changes. You'll get incremental improvements to the existing products as you're using them today. But a lot of the goodies, a lot of the things that make Lakeflow super easy to use will be things we can only do in serverless when we control the entire stack. So even if you're not on serverless, you will still get a lot of benefits from Lakeflow. But in order to get the simplest, best experience, you should absolutely be looking at getting serverless. I think it's really a game changer in the things it allows us to control, and the things that we can control are the problems we can take away from our users, and so that they don't have to worry about them anymore, and they can focus on what uniquely they know about, which is their domain and how to get value from their data.
Yeah, that's right. And I've seen, I think several features are coming next quarter. If I'm not wrong, we'll have the possibility to write to multiple schemas. We will be able to get rid of the live keyword.
Yeah, so you're talking about direct publishing mode, which is the weird internal name for what I would call making DLT simple. So when we built DLT, we spent a lot of time looking at dbt and other projects like that. And dbt had this way of referencing dependencies that were inside of the same graph. So you would say in dbt it's ref. where you say ref, give me this table. And in DLT, you would say live dot, give me this table. And it would kind of find the right version of that table. But what we realized is that was, we talked to a whole bunch of users and that was confusing them. It looked like, they didn't want to learn some new thing. They wanted to just use SQL. And this also came with a bunch of restrictions. If a pipeline is targeted at one specific schema, well, it can only write to that schema. And so the thing that we are private previewing today is a dramatically simpler way of working with DLT. So it becomes just SQL. We realize that we own the entire engine, and we own the entire catalog. So we don't need these extra affordances to tell us where to look for the table. We can just look up the table in the catalog. So with direct publishing mode, so first of all, no breaking changes. Your existing, almost all DLT code will continue to work. We'll just ignore that live keyword. And what the stuff that is coming is you'll be able to write SQL just like SQL, and it will follow the exact same rules as if you were working in a notebook or in DB-SQL. So a pipeline will have a default catalog and schema. If you just say select from table, those defaults will be used. Or if you say select from schema.table, that default catalog will be used. And same thing for when you say create materialized view, the default catalog and schema will be used. You could just reference tables. If they're in the pipeline, we'll detect the dependency. If they're not in the pipeline, we won't. We'll just read it from the catalog like normal. And finally, if you want to write to multiple schemas, all you need to do is say what those schemas are. So if you say create materialized view A.B.C, it will create the materialized view in that location. And you can use all of the metaprogramming and parameterization inside of DLT to kind of control that and do cool things, to have a separate development copy versus your production copy and all of that kind of stuff.
Yeah. And I've seen also the cool stuff about the sync. Also, I've been following the roadmap for a very long time.
No, these are good questions. And the sync is part of a more general effort. Our goal is to have full parity in what you can do in structured streaming in DLT. I think notebooks are great for doing kind of, like I said, procedural data engineering, but streaming has always been pretty declarative. The only part that is not declarative in streaming in a notebook is calling .start. And you controlling the starting and stopping of those streams prevents us from doing a lot of cool things. So you'll notice when you have a notebook and a single stream fails, well, we don't know how to restart that one single stream. We don't even know what code inside of the notebook started that stream. And so it has to restart the entire job when that one stream dies. When you switch to using DLT, we're the ones who call .start. We own that stream. We know how to start it. We can restart. We can do fine-grained retries. We can start a new cluster when there's an upgrade and get that cluster ready before we stop the old one. There's all kinds of things that become powerful. And so we really think that for running continuous streaming, DLT is the right way to do it. We won't get rid of the notebook way, but I think that's kind of always been a bit of a hack. And so our goal is to have full parity. You'll be able to write to different syncs like Kafka. You'll be able to manage checkpoints and do kind of fine-grained operations on them. You'll be able to use for each batch, even though I think you never should. I think it's a very dangerous API that I see a lot of mistakes made in. But our goal is anything you can do in structured streaming, you'll be able to do in DLT, so that you can get all of those benefits of kind of a declarative runtime while still having all of the power of structured streaming.
And just one thing before Quentin takes the lead. If you're new to DLT, there is an awesome talk at DICE. That was supposed to be Michael and Paul, but we had only Paul. But it's a cool topic. I think it's 1 hour and a half going through all the introduction of DLT, the concepts, apply change into it. I think it's super, super important because people always get confused when they try to write a DLT pipeline. By simplifying, sometimes they can get lost, but it's cool, a session to watch, and I'm pretty sure you will get everything you want to know from about DLT.
Yeah, I was super sad to miss that. I unfortunately had COVID, but Paul did a great job with it, so absolutely look for that talk. I think it's a great kind of comprehensive overview of all of the concepts you need in DLT.
All right, so let me do a recap. I think first of all, you have to start using DLT because it's so smart and the engine is doing everything for you. You still have to learn Python and SQL because the AI is not going to do everything for you. you have to use serverless with DLT because also serverless is going to help.
And not just DLT, all of Databricks.
Yeah, everything. Like, I think the best part is like notebook serverless and warehouse serverless. Like, it's so nice. You click, it starts. It's also super good to do unit tests, by the way. It's a really good way to run some SQL and see the results. Anything you'd like to add on top of that?
I think really the only other thing is think doing declarative programming is a different way to think. And I think, kind of like Reynolds gave some great talks in the past where he showed like computing something with a for loop versus computing it with SQL. And I think DLT is the same kind of mind switch. And so, if you do try out DLT, which, of course I hope you do realize it's not a better way to run Spark programs. It's a better way to do data engineering declaratively. And so it's more like writing a SQL query than it is like writing a program. But once you kind of make that mental switch, I think it can make a lot of the tasks you need to do a lot easier.
All right. Amazing. Thank you so much, Michael.
Yeah, thank you so much for having me. This was great.
Bye.
Bye-bye.